So I'm Wesley Chun. I'm a developer advocate at Google, and today I'm going to talk about building with all of Google Cloud. And it's related to G Suite and GCP interoperability, and you'll see what I mean by that as we go through the talk. So the main idea is to let people know that these two aren't necessarily separate components that don't work well together. So my job is really to bust that myth. All right, so a little bit of background about myself. So my job is to, as a developer advocate, to enable current and future developers. That's bolded because I actually spend more time in higher ed talking to students and faculty and getting them onto our cloud. So in any case, we want to have developers everywhere to be successful using Google Cloud and other Google developer tools and APIs. I was recently on the G Suite developer relations team, and so I have a whole bunch of videos on G Suite. And I write in the blogs, and I have a lot of tweets. But my professional background is I've been a software engineer for several decades. I was one of the original engineers that built Yahoo Mail many, many years ago. And I've written several Python books, and I've been teaching since the early 1980s, and I'm a member of the Python Software Foundation. And in case I have some code samples here, they will show up in a little blue box like this, and you can go and dig into it and find out more about those code samples. All right, great. So today's session is going to go something like this. I'm going to give a high-level intro, talk about interoperability, why that's a great thing. You probably already know, but just sort of like to recap all the different reasons why you would consider interop. Then I'll talk about Google Cloud as a combination of both Cloud Platform as well as G Suite. And then the main part of this talk will include lots, 5 different sample apps and case studies to show sort of like the breadth of what you can accomplish if you actually use both technologies at the same time. And then the next section after that is give you some inspiration and other apps that app ideas that you may want to implement. And just the whole thing is to really try and inspire you to kind of like think as the sky's the limit. What can you possibly do for your organization and for your customers to make them successful by using all of cloud? And then we'll wrap up with a whole bunch of links so you can get resources that you need. Okay, so why are you here? Well, interoperability is defined as having multiple disparate systems being able to talk to each other. So obviously we say interop for short, but if you look at the definition, it's just that the main point is when you have these disparate systems, they really don't have much, if anything, to do with each other, and you really want to make them play well together. And the rise of this term kind of coincides with the total number of complex systems that we've seen over time. So as you can see, as the computing era has come of age, and there's so many different vendors creating different products, whether it's software or hardware, that this term really has become more important over the last several decades. Okay, this particular talk is really meant for all of you tech leadership and decision makers out there. I guess the prequel for this talk was the developer version that I gave last year. I will show a little bit of code in this session, but if you want to see more code, dig up the link to the equivalent talk that I gave last year, so I'll give you a link to that at the very end. And the reason why I wanted to sort of like move and speak specifically more to you decision makers out there is that your job is responsible to be aware of what the big picture is and to implement solutions for yourselves and for your customers and your organization. So that's one of the main reasons why I sort of like took a little bit of a detour to arrive where we are today. Okay, so first of all, let's talk about what is interoperability and why is it a good thing? Because if it's not, we might as well just go home now, right? So the main idea is that there's more choices for consumers. Therefore, because you have more choices, you can use all of those different tools that you have to build more solutions for all, which means you have happier customers because they have choices and they have more solutions to choose from. It also encourages and embraces open standards, which is also very good. And of course, with all that, that makes it inherently anti-vendor lock-in, which is sort of a common theme that you've been hearing about at Next this year. The other thing that you gain is improved efficiency, because what happens is when you have systems that don't work well together, you have to do what? You have to create a workaround, right? And so that takes you on a detour. You have to go kind of out of your way to build something in order to be able to do what you originally wanted to do to begin with, but you couldn't because those systems don't talk to each other. And then the other thing which people don't really talk about too much is that it's financially a worthwhile cause. So if you look up the Wikipedia page for interoperability, they actually cite 2004 research in the US capital market industries saying that the lack of interoperability is costing companies nearly 16 billion US dollars. That's not a small amount, right? And it's just because of interop. That's it, right? That's kind of crazy. And without interoperability, it's possible that monopolies arise, and even worse, there may be market failure. All right, so that's really the worst case scenario if interop isn't there. But anyway, most of you probably already know all of this stuff, but hopefully this is a quick review for those who are not as familiar with why you want to do interop. Okay, but where do you do this kind of interoperability? Well, it applies to a lot of different industries and where there are many and differing systems. All right, so healthcare is sort of an obvious one. You have a lot of different medical systems out there made by multiple vendors. They all have to, move patient data between systems that don't talk to each other well. You still have to preserve privacy, but you still have to be able to give all the healthcare providers out there all the tools they need to, make sure that people are doing well and healthy and things like that. And of course, all that while supporting HIPAA and other local laws. Okay, so that's one. The military is another one. So there are multiple branches of the military. Guess what? They have to communicate with each other. They have to share knowledge. They have to share intelligence. Even if they operate differently from each other, because at the end of the day, there's soldiers' lives at stake, and so this is pretty important. And then when you look at even a bigger picture, well, between multiple governments who are allies, they also have to communicate this information to each other too, so they have to interoperate. And of course, this also applies to us here in technology. In fact, there's an entire conference named Interop, right? I mean, that wasn't created just for the heck of it. So, and by the way, this applies to both hardware and software, both inter-device and intra-device. All right. So, for example, with self-driving cars, that is a nice mixture of hardware and software interop. And it's even beyond that. It's really useful when one car is able to talk to another. They can sort of collaborate, figure out what traffic patterns are, figure out what speeds and velocities that vehicles are moving in. And if they all sort of know what each other is doing, then hopefully in the future there will be no such thing as traffic jams or accidents or things like that. Okay, so it's really, really helpful to be able to do interop. All right. Now, if it was easy, like this modular furniture that you just kind of put them together, we'd also be done. It's time to go home. The problem is interop is usually between systems that really don't, you normally either don't see together or they just shouldn't be together. All right. Then the challenge is to put them together and make them work well together. Okay. So things like, peanut butter and chocolate, they're usually not together, but it's kind of cool if you do put them together, assuming you're not allergic to peanuts. And sweet and sour, that's a pretty cool thing as well too. And Romeo and Juliet, oh wait a minute, scratch that. That didn't end well. And of course, dogs and cats. All right, so you get what I mean? So normally you don't see them together, but that doesn't mean they can't work well together. Okay, so all right, so enough of that. That's the motivation. So let's talk about, let's kind of do a quick high-level overview of GCP and G Suite so you can kind of get an idea of how they can kind of work together. So this is the main point now. We have two products that may not ordinarily seem like they go well together. Google Cloud as an organization makes both Google Cloud Platform and G Suite. And by the way, some people get confused when they think Google Cloud, they get it confused with Google Cloud Platform. Clearly they're different. Look, the icons are different. Okay, they're not the same, all right? There's also G Suite as well, too. So anyway, I just wanted to set that straight, okay? All right, so everybody remember their cloud service levels or pillars, okay? So clearly you can see that there's separation between the platforms. So G Suite APIs are all the ones that are somewhat SaaS flavored, and then GCP APIs are anything, you're playing the pass line and below, okay? That was a pun for you craps players out there, okay? So anyway, so you already know software as a service, you're outsourcing high-level applications. You're basically outsourcing an application that you yourselves don't run, right? Email is the easiest one. And then at the very bottom, you know that infrastructure is outsourcing hardware. You don't want to buy your own compute and storage, so you basically lease that from a cloud vendor. And then, of course, we have the sweet spot in the middle, which is platform as a service, where you can actually write code, you upload it, and you can run it on these vendors without having to worry about infrastructure. And then between between each of those levels, there's a little bit of gray area. Like this level it's more than infrastructure, but it's not quite a PaaS system. And then up here, we have another gray area where you have PaaS systems, but the applications are restricted to data that live at the SaaS layer. So AppScript and AppMaker obviously require, would work better if you had data that lives in G Suite, and then Force.com works pretty well if you have Salesforce data. So it's not quite as free, as freewheeling as pure PaaS systems, but they are definitely PaaS in nature. Okay, so that's how that's where they live. All right, so let's talk about GCP a little bit. So now at first you may think this is just a collection of compute, storage, networking, big data, and machine learning services for developers. Okay, but really one of the key things is not just the products, it's actually about the scale. Google has spent many, many years to building out our infrastructure so that we can actually support 8 products that have at least 1 billion monthly users. And I think this morning in the keynote, I think they revealed that there's 1.5 billion users of Gmail on a daily basis. So it's the scale is kind of amazing, all right? And when you look at a data center, when you look at a Google data center, by the way, they don't really look this pretty. This photo was done by a professional photographer. All right, they actually had to buy colored cables and everything and put professional lighting in there. It's kind of gray when you go inside a real data center, but they're still cool. All right, and they're huge. But the main idea is that on these racks and systems are running Search, Gmail, and YouTube. And if you choose to host your workloads on GCP, guess what? You're running on the same racks and the same data centers. We don't have a differentiation. All right, so any kind of improvements we make to make things a little faster, to make the networking better, to make things more secure, your workloads sort of benefit from all that we're trying to do for ourselves. Okay, so it's a great way for you to take your apps and your workloads to the power of Google. Okay, all right, so just a few things that you can do with GCP. So you need a way to host a web app that is deployed globally, that can scale, auto-scale based on traffic. Well, that's what App Engine is for. You don't have an entire app, but you want to deploy multiple microservices instead, also globally. That's Cloud Functions. All right, you want to analyze multiple terabytes of data with simple SQL and get results back in seconds. That's BigQuery. All right, want to extract metadata from images? Cloud Vision API. Got 500 million tweets about your company or product, and you want to kind of figure out what's the overall market sentiment? Natural Language API. And maybe you don't have a team of data scientists who know a lot about machine learning. Maybe they don't have the mathematics background. But you can further customize at least these last 2 APIs and several more that we announced this morning to your organization's data by using AutoML. Okay, so those are just some examples. So I'll show you just a couple of code samples in case you're not aware of what some of these products are. So this is just the hello world for App Engine. This is in Python using Flask, which is a popular web framework. And all you need for your minimum viable product is the config file, the main application file, and then your package file. And all the extra work that you don't have to think about, which is the database server, the operating system, all those things are taken care of by this big box called App Engine. We make it available on lots of different common platforms, and all you have to do is upload it and deploy, and it takes less than a minute generally, and then your application is accessible globally. So that's that. The minimum viable product for a Cloud Functions is even easier because you just have a function. All right, deployment is also one line, and once it's deployed, you can access it globally using curl or from a browser. All right, pretty straightforward. So Shakespeare's works. So this is a very well-known query that's been around as long as BigQuery has, at least 8 years. But if you've never seen it before, it's something that you really don't want to do by hand, so that's the reason why I continue to show it. It is not multiple terabytes, but it's definitely something that humans don't want to do manually. And then you can issue a simple SQL call to sort of like get the answer to this question that you've been wondering. All right, and so the main point for showing you the code is that it's not that complicated. This is a 12-line application that really doesn't have a lot of complexity to it, and you can answer that question pretty quickly. Another cool thing about BigQuery is that you get the web UI in which your developers can perfect their query and then cut and paste this directly out into their source code. So you can basically test and debug your queries, get them perfect, and then drop them into your code, and it'll still work. Okay, so BigQuery is pretty cool. Need to run sentiment analysis on those 500 tweets? Well, here's some text that you can use the natural language API on. It does 5 or 6 different things, but the 2 things that this demo shows is analyzing the sentiment of the text as well as doing content classification. Again, this is also less than 12 lines of code, and when you run it, it gives you the results that you expect. This is positive, which means the score is positive. It's not very positive because there's not that many words in this phrase that indicate that it's positive. In fact, there's only one. However, that one word is pretty strong, so that's why the score is a little bit low, but the magnitude is pretty high. And then for content classification, this is 76% chance it's internet and telecom related, 64% chance it's computers and electronics related, and 56% chance it's news. All right, so that's kind of like really basic how to use a natural language API. All right, so now that you know about all those, I'm sure many of you already know about these things, let's talk about coding with G Suite. Okay, so yes, it's for collaboration and for communication and things like that, but a lot of people don't know that behind all the apps that you're used to using, there are APIs. Okay, so that's the one catch. Once you realize that G Suite has APIs, then you can start imagining all the business problems you can tackle. And it's not only APIs, but it's all the APIs are anchored by 2 serverless developer platforms, AppScript and AppMaker. All right, so you got a spreadsheet full of customer contact information. Well, guess what? You can extract that with the Sheets API. You want to mail merge data with form letters? You can do that with the Docs API. Got a master slide deck and want to auto-generate custom slide decks for clients? You can do that with the Slides API. In fact, it's very similar to the mail merge, but instead of a form letter, you basically have a master template. You have one slide deck. You're going to go visit 10 customers. You can actually put in the company name. You can customize the company name and the corporate logo, so you have 10 decks that you can take to clients immediately. You got coders who aren't full-time software engineers, but build business apps, and you don't want them to worry about APIs and OAuth and HTTP. That's what AppScript is for. Let's see, what else? You want to build small automations with the ease of chat conversations. That's what Hangouts chatbots are for. And then if you have business analysts who don't even code at all but need to build web apps, that's what AppMaker is for. Okay? All right, so here's an example of each of those. So migrating SQL data to a sheet. You would think that this may be difficult, but again, this is a couple of lines of code to read in data from a relational database. 1 or 2 lines to create a new spreadsheet, and then 1 line to take the rows that you read out along with some column names, and then to jam those into the spreadsheet starting in cell A1. Okay, it's 9 lines of code. Not bad at all. Mail merge. Text and replace for a form letter. So I have a form letter, and the body of my form letter is here. I'm going to replace that with a hello world. 1 call to the Docs API, and then it's done. Obviously, you're going to have a lot more text to search and replace, but this is just 1. You'll actually have an array of requests, and they're all going to be the search and replace ones, and then you can send all that over to the Docs API. So the similar one for the slide template deck. So this one will replace your customer name as well as their corporate logo. Also 1 call to the Slides API, and then it's done. Okay. So again, all these have, the ones that have videos also have a code sample, a full code sample that you can take a look at that actually works. So just keep that in mind. So AppScript, if you've never seen AppScript before, this is a 1-line JavaScript application that all it does is fetches cell A1 out of the current sheet, and it just writes hello world into it. Now, it doesn't look like it's much, but however, it's really exciting when you actually run it and you actually see text that's in a spreadsheet that you didn't have to manually type in. Once you realize that you can write code to make it happen, this is where your gears are going to start turning and it starts getting more exciting. All right. So obviously, hello world is your bare minimum. It doesn't really, this is not a very useful application, right? So let's take 1 step further and try and find something a little bit more useful. Like, what can you do with this? All right. This happens to be the address of Google's office in New York. So that's a piece of real data, something that you may have in your own spreadsheets in your organization. Well, guess what? We can write a 4-line application now. I'm going to connect to this current spreadsheet. I'm going to get the cell A2. And this time I'm going to pull out the value instead of setting it, and that's the address. Then I could say, hey, Google Maps, can you make me a new map and put a pin on that address? And then the last line is, hey Gmail, can you email this map to my friends so they can join me for lunch at the Google office in New York? All right, so this is 4 lines of code. It touches 3 different Google products, Sheets, Maps, and Gmail. By the way, you're not constrained to living in the Google world. You can use JDBC and talk to relational database. You can use URL fetch and talk to any service that's accessible from that machine, from Google, basically any publicly accessible service. All right. So you're not really tied into Google. It's just that one of the cool things about AppScript is that it gives you access to more than 40 different Google services, and they go beyond G Suite and GCP, for example, Maps and Analytics and things like that. So there's a lot of options available for you. And notice there's no security code here. There's no OAuth code you have to write. It's handled for you automatically. The scopes are determined based on the access that you're the code is trying to do. All right, so you can actually write pretty useful apps, and it's pretty high level, so it's pretty easy to use, and it's serverless. So you don't host it yourself. We host it for you. Okay, and so based on that app, guess what? Now you can take that code, that 4 lines, and do something more useful. Like maybe you want to plot out the 4 clients you want to visit in Manhattan today. Well, since Google Maps has walking directions and driving directions, and as well as public transit, you can probably map a nice route for yourself. Maybe you have a monthly user group or a book club. You want to be able to kind of like let people know when and where to go every month. You can use a Gmail API to send out emails. You can actually use the calendar API to put the events in their calendars, right? So you just have to kind of like think outside the box. What kind of things can I accomplish? Maybe I want to kind of like show customers like where all of our stores are, and things like that. So there's a lot of possibilities. Okay, and another interesting application. This one was actually written by my summer intern 2 summers ago. And we took him on a trip, and he did his first expense report in his life, and he didn't like it, okay, because he's a student. And he was like, gosh, I get all my receipts in Gmail. Why can't I just do my expense report here? Why do I have to like cut and paste things out and send in receipts and stuff, right? Because I already got it in my email. So at this time, we were launching Gmail add-ons, which came out in 2017. And so what he did was he wrote a Gmail add-on, which is an application that runs alongside Gmail. And you can kind of see that we're in Gmail now with this rideshare receipt. So I'm going to sort of unhide the rest of this, which is, unfortunately, the AppScript logo is covering the little strip of add-ons. But there's one that looks like a receipt. So when you click on it, the code using regular expressions will extract out the vendor, the date, and the amount. All you have to do is plug in a spreadsheet URL and click on Submit. Now, the other cool thing about Gmail add-ons is that you write your code once, and it runs on Gmail on the web as well as on the Gmail mobile app, and you don't have to write a separate web version. So on the web, it looks very similar. The only difference is that the little add-on icons are on the bottom, so you have to click it from the bottom, and then the form pulls up. But everything is the same. The same code that rendered this form is the same code that rendered this one on a mobile device. And once you have that, once you click on Submit, it says it logged the expense successfully, and now you have a spreadsheet that you can send to your accounts payable folks, or get your manager to sign off, or export as PDF or CSV or whatnot, and boom, you're done. Okay. Another interesting app is you can write interesting bots with Hangouts Chat. So Hangouts Chat is the next generation messaging platform, and one of the things that differentiates it from old Hangouts, or classic Hangouts as we call it, is that you can write bots for it. So at first this may not seem game-changing, okay, but so last year when we launched this product, the Motorola CIO did something very interesting, and he did it very, very quickly. We actually launched this product on the last day of February in 2017. 6 days later, he wrote a blog post on LinkedIn and described 2 bots that he wrote, which immediately started helping his company. He wrote an ERP bot that allows a customer service representative to take an order number. And once that bot gets the order number, it goes back and talks to a bunch of completely unrelated systems, all right, part of the interop theme here, and it returns a list of which products in that order are still under warranty, all right, just from a chat interface. The CSR doesn't even have to talk to anybody or log into weird systems. That's all done by the bot code, and instantly they have something they can talk to the customer about. Another one he has queries their enterprise data warehouse, where for any given calendar day that he sends in a chat request, it will give him a summary of the total shipments in US dollars for that day, and it's also able to show the top 10 shipments for the entire day. So 2 bots in less than 6 days. It was pretty amazing, and we didn't sponsor him, we didn't pay for him to do it. We were just as blown away as everyone else hearing about it. So it's pretty cool. So if you want to read the blog post, there's a link to it down there. And here's just one example of a bot if you're curious what the code looks like. This happens to be an AppScript example, but you can write Hangouts chat in any language, hosted on any platform, use any cloud, even on-prem as long as it's reachable from the internet. So the main idea is your bot is located anywhere that Hangouts chat can send an HTTP post to. That can reach on, you can reach it online, then you can host your bot there. So this one is probably the most unrestricted platform we have because you can use any language and host it anywhere as long as it's reachable by a Google server. Okay, so this is just an example of a vote bot, like who wants to come to lunch with me today? So people click yes, or they change their mind, or they click on a new vote if they want to vote on something else. So it's pretty basic. This is starting a new vote, and this is incrementing and decrementing if they do +1 or -1. So it's pretty easy to write a bot. And then AppMaker, I'm not going to show an example of it, but this is our low-code assistive development environment where you don't have to code at all. You basically build an app by dragging and dropping components onto a canvas and then connecting to a back-end data store. It defaults to Cloud SQL by default. So already we're having some synergy between G Suite and GCP here. There's a lot of pre-made templates, apps for very common business cases that you can just use right out of the box. If you do know JavaScript, you can modify it because it's actually AppScript code, but you don't have to know how to code. It's just that if you do, you can further customize your apps. It does require you to have at least G Suite Business and higher though. But anyway, we launched this one at Next last July. Okay, so now that you have an idea of what you can do on the GCP side as well as the G Suite side, let's do the magic part, which is actually showing you how you can sort of like merge both technology together to build very interesting apps. These apps are very different from each other, as you'll soon see, okay, but they each have elements of GCP as well as G Suite. Okay, so yes, G Suite and GCP APIs are individually great, but let's do things in an all-together now type of theme. Okay, so one thing that's really helpful is that you actually turn on GCP APIs and G Suite APIs in the same developer console. So that's the first place of interop. You don't have to go to 2 different places to turn them on. You turn them on at the same time in the same place. All right, so here's Google Docs next to Cloud IoT, next to Cloud Endpoints. All right, and Google Slides is there as well too. Okay, so that's cool. All right, let's skip all that and go straight to the apps. So this is an app that we demoed last at the talk at Last Next, and we showed more of the code, but this time again we're focused on the use cases and less on the code. So if you actually want to see the code, then look up our talk from last year. Okay, so this is code that one of my colleagues wrote that adds custom intelligence to Gmail, and what it does is that it analyzes G Suite data using GCP. So here's the background. What's the motivation? All of us get a lot of email every day, and Gmail does a great job at filtering that spam, right? However, even with your non-spam email, there's too much email. Maybe we want to focus on only certain messages. And his particular use case is he's only interested in email messages that have attachments of pictures with birds in them. Okay, so roll with me here. Okay, it sounds like a weird use case, but how was he able to make this work? All right, so here's the diagram of how the app works. When a new message comes into Gmail, that sends a notification to Cloud Pub Sub, which is our message queue service. What that will do is that will send the message over and kick off a Cloud function, which then extracts the attachments from the email body. And then it sends that over to Cloud Vision. So then Cloud Vision will return metadata for what it sees in that image, and if it happens to see that bird is one of the labels that's returned, then he calls the Gmail API to star that message, so that by the time he logs into his email without explicitly running any code, he will already have some messages that are already starred to basically raise awareness that these are a little bit higher priority because they have pictures of birds in them. Okay? Kind of crazy, right? So that's a very interesting use case of both. So if you want to learn more about this particular app, especially its functionality, like how do I get Gmail to notify PubSub that a message has come in? So there's a link for that. How do you get PubSub to trigger a cloud function? There's a link for that. All right. Cloud Functions, of course, gives you serverless access to GCP APIs, and then you just combine all of the above to add custom intelligence to Gmail. Later on, let's see, maybe a couple months after next, he published a blog post that actually detailed this app in much more, much more detail. And if you want to just skip all that and go straight to the code, it's available at that open source repo there. All right, so that's the first app. The second app is one that I wrote, which is going from big data analysis all the way to slide presentation. So this is accessing GCP tools from G Suite. So in a situation where you've got a lot of, you're doing a lot of data analysis, you're using our big data tools like BigQuery. Okay, you're doing, whatever you're doing. Here's the Shakespeare query, but you're doing whatever you're doing. You're perfecting the query, but now what do you do with the data? All right, you have a couple of choices. One is you can download it as CSV, or you can put it into a database. But I contend that is not visual enough, right? You're not going to go to your manager and go, hey, just check out the database, right? This is not going to work, right? You want to at least put it in a presentable format. So I would say by doing all the big data analysis and getting the results that you're looking for, you've done 80% of the work. It's like these stairs that you see here. It's 80% done, but it sure can be a lot prettier. Right? You can use them, but really, it's just not something that you want to show managers. Okay? So what I'm trying to encourage people to do with this app is go the final mile. You've done the 80%. Just spend a little bit more time perfecting it and making it look nice. All right? So clearly, a spreadsheet is much more visually appealing than a database or a CSV file. And since you're already using the Sheets API, you might as well tell Google Sheets to make a chart from that data too. Right? Because that's what you have that capability when you're using the API. Okay, and then on top of that, this is great, but that's still not visual. What are you going to present to your managers, right? What are you going to do if you have to go to the C-suite and kind of say something to them, right? You probably want to have a slide deck, so why don't we import that data into a slide deck? And once you create the chart, guess what? You get a chart ID, so you can import that too. All right, so I mean, there's nothing to stop you from doing that. And so now we've gone from big data analysis all the way to a nice presentation that I can take to my managers. Okay, so let's see how this app is put together. This is an AppScript app. Sitting at the console, I'm making a call to BigQuery. When the results come back, I store it into a spreadsheet. And then I tell the Sheets API to make a chart. And then I take the data as well as the chart and import it into slides. And when I finish, I would have gone from big data analysis all the way to exec-ready slide deck. And this sample application, if you remove all the comments, it's less than 100 lines of JavaScript. Less than 100 lines. It's not that much extra work to add on the last part to make your data more visually appealing. Okay, obviously you can put it into a dashboard as well too. But having a slide deck available for you, as soon as, when you run this code, it runs the BigQuery query, and by the time it's done, when you look into your Drive folder, you'll have both the slide deck and the Google Sheet waiting for you. Okay, so it's just like, armchair analysis. All right. Cool, so more information about this app. I have a code lab, so for all you developers out there, you can build this line by line. I also created a video and a blog post on this. If you just want to skip all that and go straight to the code, there it is. Here's the link to our talk from last July. And then this is just a link to this talk that we're at today. Okay, let's move on to the third example. So this is done by my summer intern for this past summer in 2018. So he wrote a Hangouts chat productivity tracker, which is a chatbot that is GCP and G Suite aware. So what is the story behind this app? The main story is that when he goes back to school, he needs to have side jobs to make ends meet. So he contracts out. Of course, he has homework. He has other tasks he has to do. So he has a very busy day. And when he gets home from school, he wants to sort of know, is he using his time well? And for the work that he's doing as a contractor, he wants to be able to get paid for the amount of time that he puts into it. So he needs to be able to track when he's doing tasks for those contract jobs. So he has a whole bunch of reasons to create an app like this. Okay? And it works something like the following. He gets home from school. He starts a work session, sort of like a daily work session, by sending a message in Hangouts chat. Hangouts chat will then contact his bot by saying, I want to start logging everything, or I want to send individual things like, oh, I finished my homework, or I started working for, Acme company, or I had dinner with Joe and did some homework. So he basically logs each task, and all that information goes into Cloud SQL. So start creates the instance of Cloud SQL, or the table at least, and then log will add each entry as he completes each task. And also, of course, the timestamp goes along with that. And then the last thing that he does at the end of the night, when he's done, he types end or stop. And what that does is that also goes into the database. But on top of that, it also extracts all the data that he's done for the day. It sends it to the Cloud Natural Language API, which extracts all the pertinent information and tries to make sense of it. Like, he had dinner with such and such. He performed tasks for this company. And so, of course, the timestamps go with it. All right, so all of these things are part of the analysis. That all ends up going into a spreadsheet, which you can then sort of like print out and sort of like fill out his timesheet for the contract work that he's done, and also he could see how much time he spent on each task to see whether or not he's using his time well. Okay, so that's this bot, and you can see for all the diagrams, you'll see like a G Suite side and a GCP side to see how things kind of like go back and forth between the two. So for this particular app, here's an example of what he's doing. You can it goes by pretty quickly, but you can kind of like see a few things, and when he's done, he'll click the link and go to the spreadsheet. So this is just an animated GIF for you guys to see how it goes. Okay, but anyway, so this is a fully working app, and the code is available. So he basically used the Hangouts chat bot framework and API to build a useful bot to help him sort of like track his time work, his time spent on work, learning where he can be more productive. But in general, when you're writing any kind of bot, just like the example with Motorola we saw earlier, the main idea behind writing a bot is to help automate workflows, to query for information, to do other kind of like heavy lifting, meaning connecting to multiple systems and that don't normally talk to each other, and sort of collate all the information in one place in a chat room, which is very easy for users to kind of like communicate with. It's a good user experience because they don't have to get an app. They don't have to you don't have to have a custom app that you have to run. You don't have to log into a specific website. It's just Hangouts chat. They're just sending chat messages, and you're reading chat messages. All right, so the user interface is pretty easy. So anyway, so this is a G Suite app. So a Hangouts chatbot is a G Suite app that leverages app hosting and natural language processing, because he did it on using App Engine. He used the natural language API as well as Cloud SQL, and the code is at that link here. And he presented this at the Google Developer Group in Silicon Valley last August before he went back to school. We're going to try and get the video and blog post for this out soon. Of course, it kind of has to come after Next. Everything is all about Next right now. So, okay, cool. All right, so that was his first summer project. And of course, he took a little while to do that because he had to get up to speed. So he didn't leave a lot of time for this second sample that he did. But this one I think is pretty cool too. So this is using Google Docs as a coding IDE, which means that it basically allows you to run Python code, to write Python code in Google Docs and have it run using the help of GCP. So how does this one work? All right, so this one, the motivation behind this is so when he's in school, he's actually one of the lead TAs at Carnegie Mellon. And there are some professors that are teaching non-engineering majors how to code. There's coding classes for non-engineering majors and who are not familiar with using IDEs and things like that. And so just to make it easier, he thought this would be a good idea, which is allowing students to actually put code in a Google Doc and having that code get executed. So the professor, who's up at the top here, will say, hey, you know what, I'm going to call a cloud function. All right, so basically it's kind of like a web app. It returns a web page. It has a form where the professor can request a new roster. That will go to Google Drive, where he takes a sort of like a master template spreadsheet, and he copies it for this new course that this professor is teaching. The professor will then add the students' names and email addresses to the spreadsheet, and then he runs the cloud function again, but instead of new roster, he's going to ask for a new editor. Okay, and that will go to Google Drive, which will copy a master template Google Doc. And it's going to make a Google Doc. Well, first it has to extract the student information first. And then for every student, it makes a copy of the Google Doc, so every student gets their own Google Doc. Then the students are notified because their email address is in there. I hope you use the Gmail API for that, which is not in the document. So the student will edit the code into the Google Doc. Then the student will go and go to the Cloud Function. So they get a special web page just for students. And what the student's going to do is going to request that this code gets executed. So it's going to first go to Google Docs to get the code. And then what it will do is, to run the code, it will launch a Google Compute Engine virtual machine. In the startup script, it will install Python. It will then take the code, run it, execute it, return that back to a Cloud Function, and then the Cloud Function will write that back into the Google Doc. And then, I don't have a skull and crossbones, but then the VM is killed. Okay, so this is this application. A little bit more complicated, but it's a very interesting way of using both GCP and G Suite APIs. So here's an idea of how it works. Here's the students typing some Python code. There's a link to the Cloud Function, and then once you run it, it will automatically write the output back into the Google Doc using the Docs API. Okay, all right, so again, the motivation was, as a TA, he's trying to manage student coursework. He needed a roster app for non-engineering faculty for student coding, and he wanted to use the two new products that we had at the time. So the Google Docs API didn't really launch until earlier this year, and Python was announced at last July's Next. Previously, when Cloud Functions was out, we only supported Node, but Python was added, so he wanted to use the new shiny objects. So the way it worked was he used the Drive and the Sheets API to create the student roster for the professor. The faculty completes the roster, and the sheet calls the Cloud Function again. It auto-generates a Docs quote IDE for every student using the Docs API. Student edits the code, then it calls the Cloud Function to run the code, which is read from the doc, spins up a VM, runs the code, writes it back to the doc, and then takes down the VM. So the application code will be here once it is published. It is not published yet. It's still going through final approval. Also, I need to fix a few outstanding bugs that he left behind when he went back to school. So I know this because I actually had to make this thing work. So it does work, so it's pretty cool. All right, and the last example was given by was an application that one of my colleagues described yesterday. If you were in Theater 10 at 5 o'clock yesterday, you went to see my colleague's talk, which is serverless using GCP and G Suite. And so her app was a lightweight sales inventory web app to help on-floor sales team at a retail outlet connect to the back office inventory software. So the main idea is that they have all their data in a spreadsheet. There is there's a SKU, there's a price, there's a current status, there's an image of the item, and as well as some vendor information. And the main idea is this is not really visual or that useful on the floor, because if a stock person or a salesperson is trying to find whether or not they have something in inventory without being able to see the picture, it's not going to be too useful. So instead of having a spreadsheet where they have to individually click on each image to see them, it's much easier if they could just look things up with a simple lightweight web app on their mobile device as they're walking through the store. Okay, so the main idea is to turn that spreadsheet into something like this, but with a little bit even more information. All right, so the way this app worked originally is everyone had to do everything through a spreadsheet. All right, so you could add new items to the spreadsheet, you can update inventory values, you had to do everything through the spreadsheet. That was the way it originally worked. But that's not the best way of doing it, as I just mentioned before. So she created a get inventory cloud function, which will then read the data from the sheet using the Sheets API and return that back to the user. So that's one thing. However, she was thinking, wait a minute, well, every single time somebody refreshes the page, it has to make a call to the Sheets API. And at some point, if you have a very busy day, the Sheets API is going to get hit a lot and it starts eating up your quota. So why don't we make it a little bit more scalable? And so she extended this application by adding a new menu item on the sheet, so that when a new item is put into the spreadsheet, or when inventory numbers change, what it'll do is the user can make a request to export the data to a different cloud function that will write that data to a Cloud SQL instance. And then that data can be sent to the cloud function that that is called when the user calls get inventory. So now all of the gets come from Cloud SQL now instead of the sheet. So that's one way to reduce the number of overall calls to the Sheets API. And then on top of that, she wanted to add some intelligence to this little application. So analyzing the image of the data and then sending it to Cloud Vision to extract some search terms which you can index, such as color, style, price, and things like that. So now all those things show up in the web app. So not only do they see inventory information, but if a customer comes in and asks for all shoes that have the color carmine in it, you could actually do now a search for carmine, and it will actually pull up all the shoes that have that, because the Vision API returns a color as well as the items. So this is that system. Okay, so if you want to learn more about it, here's some more details. So the main, again, motivation is to help the sales floor staff with store inventory and customer information. So GCP helps Sheets scale and provides machine learning capabilities, and the web interface is really for scale and convenience for the users, the sales folks that are on the floor. And this application uses both G Suite and GCP APIs to build a web-friendly interface, and could be used not just for on mobile, it could also be used on a computer as well. It exports the Sheets data to Cloud SQL and allows users to make information requests whenever they want and not have to worry about any kind of quota issues. And by using the Cloud Vision API, you're able to sort of add a little bit more intelligence to that data. And it also enhances the user experience, both the sales staff as well as the customers.